I'm Todd Hines, a co-founder of Climate Scale Up, where we help bring climate and energy CEOs to Davos to help them access this amazing network of global leaders, potential investors, customers. And today we have a group of CEOs that are going to talk about energy and abundance and the importance of bringing more energy more rapidly to humanity, in a distributed way as well, to help the broader energy needs as well as AI energy needs. So, Jake, why don't you start things off?
Yeah, so I'm Jake Chorotz. I'm the co-founder and CEO of Blue Energy. We are a small modular nuclear power plant developer, and our key approach and key technology is that we prefabricate nuclear plants using oil and gas fab yards and shipyards. So basically the supply chain for offshore oil and gas and offshore wind. So we can enable project financing for nuclear for the first time. And really what that means for those who don't know what project financing is it means that for the first time we can build nuclear plants that are not put on the backs of taxpayers or ratepayers, but we can privately finance them with fixed price contracts and known schedules and finance them the way we've been building wind, solar, natural gas for many years. This is the key unlock that will enable nuclear power to broadly scale globally to meet the growing energy challenges that not just AI is posing, but many other economic growth areas as well.
Well said. I'm Shiv, CEO and co-founder of Active Services. And similar to this theme of energy abundance, we live in a world where electricity prices are going up, and what we need is the cheapest form of electricity that we can get. And today, that's solar. But the problem is these solar modules that we know, these rigid 30 kilo, 1 meter by 2 meter bricks, they're heavy and they're tough to install. And the modules may be cheap, but the soft costs dominate the installation and make it prohibitive in a lot of markets. So what we've invented in the labs of MIT is something that is significantly lighter and can unroll like a yoga mat. Imagine deploying this on rooftops, facades, cars, any surface. Any surface can then be the future power plant.
Cool. So my name's David Peter. I'm the CEO and co-founder of Gridfar Fusion. Our mission is to give humanity the power to achieve our dreams by delivering clean, limitless energy at a price the world can afford. We are effectively fusion's answer to the small modular reactor. We are machines that are about 10 meters long. They can deliver about 15 megawatts of net electric. They're cheap to build, cheap to maintain, which is crucial, and fast to iterate on, because this is the big challenge for fusion. It's actually not fusion itself, or that's still a goal that everyone's running towards. It's actually how you're going to deliver maintainable baseload at a price that people can deliver, and that's what we're based on a machine that was built at the University of Maryland, funded by the DOE, which our team constructed. MIT came down and validated the results from, which already puts this machine that was only 4.5 meters long in the mid-table of all fusion machines ever created.
So one of the key aspects for getting energy production out in the world is deployment. So getting these on rooftops, said facilities. So talk through how you can use your technology to accelerate the deployment of these systems, because there's obviously a lot of different types of options right now, but one of the big challenges is deploy. So tell us how you solve those problems.
Yeah, I'll start. So I think I grew up in the construction industry. If you're following construction nowadays, you know that particularly in the US, there's a craft labor shortage. It's hard to find the plumbers, the electricians, the steel workers to build all the data centers we want to build, which means it's particularly hard to find them to build all the power plants we need to build those data centers. So one of the key things that we're doing, and we are actually a reactor technology agnostic company. We work with many reactor technologies, but our approach is being able to leverage that existing supply chain from where we build big things already. So that there's already oil and gas fab yards down around the Gulf where you've got 6,000 skilled laborers who've been building oil and gas platforms, offshore substations for many years. We're taking that labor force, we're taking that existing manufacturing base and welding and crane capability, and we are building the power plant of tomorrow. And then we're relocating that plant by barging it to sites where we want to operate it. This means that we don't have to put up all that capex to build the factory. So it's not just about building the first plant and building that. You have to finance that whole factory. We can use the factories that already exist, using those shipyards and fab yards, reducing the amount of craft labor you need on site, making it much easier to scale this up very quickly.
Yeah, well said. I used to work for ExxonMobil in Louisiana, and finding a way to reuse a lot of that infrastructure is powerful. From our end, there is a labor shortage, and when we want to deploy more solar on buildings, it's not how do you get this out to more buildings and call it a day. It's how do you actually, with the same labor force, with much less time, deploy a solar as fast as you can. And the two big constraints right now are schedule, so being able to deploy this technology in a fraction of the time, and the weight of the technology. A lot of buildings just can't handle the weight of not one module, but thousands of modules, along with racking and ballast. So if we can solve those two problems, something that's easier to install, takes less time to install, then you can actually deploy much faster.
So for us, I mean, what's the most exciting thing for Fusion is the regulatory pathway that's now been agreed. And funnily enough, we're an American company, but we're actually building in the UK, which people sometimes take a moment to get their head around. But the UK has set the regulatory environment for Fusion now, where we're regulated like a cancer treatment center or a particle accelerator. That's huge. That's one thing that's accelerating, moving us towards deployment. But the other one is very similar to you, where Fusion traditionally has built these giant cathedral-like machines, even the ones that are more compact, the tokamaks accelerators. These are still huge machines. The point that we believe is that that's what governments are going to do, whereas actually smaller machines that are modular can use existing infrastructure that exists. So for us, we're targeting the nat gas space, where there's a lot of plants that are coming towards end of life. There's a 9-10 year wait already for nat gas turbines, whereas you could drop us in as a power core into that. Our outlet temperatures are 650 degrees plus, meaning you just put in a better steam cycle, but you can use the existing infrastructure. That's so important if we're going to actually deploy rapidly, admittedly for us, not tomorrow, but have all that laid down.
Well, it's great to hear how each of you in your own way are leveraging the existing infrastructure of different industries to really scale your technology versus trying to do it all from scratch. So congratulations on all the progress, and we hope that your week in Davos goes well. So thank you for joining Climate Scale Up and the cohort this year. We have several of our CEOs here to talk about their business and how they can help address the resilience issue that's facing the world. So.
Great. So my name is Jarno Huinen. I'm CEO and co-founder at Volare. And what we do is we upcycle food industry side streams that are currently used not very efficiently. And basically what we do with them is we upcycle them into a protein ingredient and an oil ingredient, which can be used in aquafeeds, in pet foods, and in the chemical industry. So basically we take materials that are currently, for instance, burned for energy, and we turn them into materials that replace fish meal, soy, meat bone meal, and palm kernel oil in several applications. And we do it on industrial scale, building our first factory in Finland as we speak.
Hi, I'm Susan Hunt-Stevens. I'm co-founder and CEO of Tussie, and we help people rebuild homes after natural disasters. And we do that by using AI to automate damage assessments and then connect people based on those assessments to the capital and the labor to rebuild.
Hi, I'm Kelly Harrison. I'm from Alpha Whitby Wood, and we work with real estate investors and multi-asset owners to ensure their portfolios are resilient to climate, resilient to energy transition, and resilient to social change, trying to find the interdependencies and sweet spot between the three.
One of the emerging challenges facing the world, which people are starting to focus on, is resilience, and this is becoming a bigger and bigger issue. Kind of talk through how your companies are looking at that specific problem and trying to address it in a time frame that can really help, given the scale of the problem.
Yeah, so I really see that resilience is very much linked to circularity. And circularity means that you can do things locally. So currently we have protein value chains that reach from like all around the globe, from Latin America to Europe. And there's huge self-sufficiency issues in Europe when it comes to protein ingredients, specific ingredients. And the way we see it, the more you can do things circularly, it basically means you're doing them locally. So having more resilient supply chains when it comes to protein. And that's just one example of how we see it. Also leveraging the resources that we already have instead of burning them for energy uses, for instance.
So adaptation and resilience is a hot topic here at Davos this week. And one of the things I think to think about in this is innovations can lead to new systems and systems changing. And if we think about a really broken system, disaster response is certainly high on the list. At this point, 5 people will come to the average home and do the same assessment and get a different number and create a lot of confusion. There's a lot of fraud, lack of transparency. And so what's really cool about a lot of us here is not only are we creating new inventions, these inventions are going to fix broken systems and make us more resilient and or lead to better adaptations so that we can stand high heat, extreme storms, and other kinds of things that climate change is exacerbating.
I completely agree with exactly what you just said. It's been great to connect with you, Susan, because I think it's really similar in terms of construction generally and the need to retrofit and upgrade our building stock. And so, we as I have an engineering background, and in that space we get frustrated because we have so many barriers in the system to actually do the resilient thing that we want to do. So we set up Alpha to try and get the investment team and who are thinking much more long term to be driving that agenda and trying to implement that system change.
One of the major attendee group and audience for Davos is large asset owners, and climate risk is an increasing real risk to those assets and infrastructure. What would be the one thing that you'd want to tell them that they need to be concerned about, and what they should do about it?
I mean, at the moment, there's a lot of talk about these things and like really bad scenarios that are laid out. I think the food system has still not gotten enough sort of focus on this area and attention, basically. So I think that's something to highlight because all of us need to eat. We're soon going to be 10 billion people on this planet, and at the same time, as people are getting wealthier and healthier, they need more high quality proteins and ingredients. So that's something that I'd like to highlight. There's a lot of noise and a lot of important stuff happening in the world at the moment, but food is going to be essential going forward.
And the existing system is fragile and
Very
be
fragile.
impacted very negatively by climate change. So having a resilient
Exactly.
alternative path is important. So, Susan?
So in the building space, I think the number one thing asset owners need to be thinking about is the models are wrong. It's worse. It's way worse than the models are saying in terms of your likelihood of your property being affected by a natural disaster, a heat emergency, things like that. And every dollar put into resilience and adaptation puts $10 out on the back end. And the number one place to focus is code and exceeding codes and looking at what the top level codes are and at least building to that, if not stronger.
Just real quick to that point, I'm the chair of the board at the Woodwall Climate Research Center, which is one of the leading providers of independent climate science. And we've been helping major asset owners like Wellington Management understand climate risk and what's coming. We're also doing that with communities, cities, countries, states. So there's definitely a way of seeing what's coming, and taking action is really what we have to do before it's too late.
I think I couldn't agree more with that. I mean, I think that's the big thing that I've learned this week by joining the Climate Scale Up cohort is I've been so exposed to so many amazing emerging technologies coming out, and I'm keen to ensure that they're deployed at the right moment, at scale, in the right way in real estate. And I think that's a big thing that we need to do to get the resilience of the system.
Absolutely. Well, thank you so much for making the trip to Davos and joining the Climate Scale Up cohort.
Thank you. It's been great.
All right. We're going to let them introduce their companies a little bit and then get down to it. So, Erica, why don't you tell us about your company?
Sure. I'm Erica Nemser. I'm the CEO of Ardent, and we develop and deliver carbon capture solutions for power generation, among other industries. And that topic, power generation for AI and supporting data centers as they grow and expand, is definitely a big topic in the world and here at Davos. And so I'm here talking about how we can help decarbonize that power.
And I'm Tim Heidel, co-founder and CEO at Veer. At Veer, we build superconducting power cables addressing critical power delivery bottlenecks in a lot of different scenarios, but we spend a lot of our time focusing on data center power delivery today.
All right. Well, tell me how both of you have been engaging with data centers. Are you engaging with the hyperscalers, with the people that are building the projects? I mean, how are you engaging with this part of the sector?
Yeah, so the data center industry is a full ecosystem with a lot of different stakeholders that all have a role to play in the adoption and scaling of new technology. So we work very closely with the hyperscalers. Microsoft is one of our investors. But we also work deeply with the electrical OEMs that supply equipment to the data center world today, right? Even when you implement a superconducting cable inside of a data center, it still needs to connect to switchgear. It still needs to connect to the UPS systems. And so those OEM partners are really important. They also have global reach in their sales and their marketing and their supply chain and manufacturing as well. We also work a lot with architects and data center designers to help them understand how do you best configure and optimize your data center layout using superconducting solutions, where you can get to much higher power density, you can deploy a lot faster using far less labor, far less concrete, far less copper, and ultimately get to higher density facilities that can actually operate with higher performance.
Excellent. So with carbon capture, we capture the carbon that comes out of the natural gas combined cycle power plants that feed the data centers. And so we end up working a lot with the companies that are providing that power and sequestering the CO2 as they deliver those power solutions.
One of the challenges facing the data center build out in the AI space is the pace at which you can build new facilities and new resources, new assets. Can you talk a little bit about the opportunity with existing data centers or existing facilities? Is that something that you can also address?
I think that one's mainly for you.
Yeah, so most of our conversations today are on new build, right? There's just so much interest in building larger data center campuses than we've ever seen before. But we do think there's huge opportunities for retrofit. And unfortunately, the latest generation server racks and GPUs drive power consumption needs far above what they were just a couple of years ago. So a server rack inside of a large AI factory today is consuming hundreds of kilowatts. That's up from, say, 10 to 20 kilowatts just a couple of years ago. And in a couple of years, that'll be a megawatt. And so often in these existing data centers, you don't have the bus bars and the cables, and you don't have the space to implement more bus bars and cables to move power to very dense racks. And so in a lot of cases, you have to actually depopulate the data center, and it's actually mostly empty. With a solution like ours, we can actually rip out the existing bus bars, put in new ones that match the size and match the weight of the existing solutions, but can deliver 10 times more power and allow you to get 10 times more computation into that same facility space.
Similarly, we see a lot of pickup with the new data centers. And because when you want to do carbon capture, you need to be sited in a place that you can sequester that carbon nearby in order for it to be cost effective. And so what we see is for every data center that wants to go in their ground, they're kind of looking at it as a two-step solution. First, let me get that data center sited and up and running very, very, very quickly. And as we all see, those timelines are shrinking from 48 months to 24 months to 18 months. And then step two is getting the carbon capture system online.
All right. Well, we do have a bit of a global stage here at Davos. What would be the one thing you want to tell, the world about what you're doing and why it's important?
Well, so energy access is the gating factor in who's going to win the AI race. And increasingly, we're going to continue to see bottlenecks show up in the electrical labor for deploying these systems, the supply chains for conventional conductors, and ultimately the highest performance data centers that can train models the fastest will win. And I think that's what we're really excited about superconducting, to be able to offer a whole new class of superconducting data centers over the next couple of years.
I would say the big message is there doesn't have to be a compromise between decarbonization and data center growth and energy consumption. We can deliver carbon capture solutions to decarbonize that energy, whether data centers are making a choice about supplementing what they're already purchasing, that's renewable energy, with single cycle, combined cycle natural gas, and siting that in a way that they can capture that carbon. All of those options are available, and we can do that in a way that's the lowest energy consumption and lowest cost solution available.
All right. Well, we are in one of the best places right now. We are at the Dome at Davos. Today is all about AI at the Dome. It has to be the epicenter of the world right now, with MIT, Stanford, and people from all over the world focused on AI all day long. And it's fantastic that you were able to join for this event and for the Climate Scale Up cohort. So thank you very much. I'm here with one of our CEOs, Ori from GigaBlue. Ori, why don't you tell us about your company?
Hi, Todd. So GigaBlue sequesters carbon in an affordable, scalable fashion in the open ocean, biomimicking the natural biological pump in a way that has two types of impact, both on ocean health and climate resilience. So once you remove CO2 from the ocean, you are reducing ocean acidification and temperature, so the two silent killers of the ocean. And the second thing that happens, CO2 from the atmosphere basically is balancing itself into the ocean surface, and from there we take the role of exporting CO2 from the ocean surface to the ocean sediment. This way, CO2 joins the natural carbon cycle, the slow carbon cycle, and gets removed from the atmosphere for hundreds to thousands of years.
So Earth is over 70% water. It really should be called ocean, right? So, we're here at Davos, which is a global platform. What brings you here? Why are you coming this week, and what do you hope to get out of it?
Last September, after years of research and development and collaboration with scientific parties from all around the world, we have released MCFS. MCFS, microalgae carbon fixation and sequestration, is the first pure Earth validated methodology that can enable us humans to harness the power of photosynthesis. This is huge, like nothing comes close. It's the largest energy process on the planet. And when you're trying to solve a problem as big as the ocean and the atmosphere, you can't just do it with facilities that are limited by energy and terrestrial real estate. Those things won't fly. So this is not new, right? We have been trying to do this for many years now. There have been attempts in the 90s, in the early 2000s. And the release of MCFS is big news, not only for GigaBlue, but for the world. That's why I'm here. People need to know this, and we would like to see MCFS adopted in more geographies by more companies.
So engaging with the global leaders and major corporations. But in terms of a global platform, what would you want to tell the world if you were to say very briefly to the average person just listening in for a little bit? What would be the one message that you'd want to share with them?
Urgency.
It's
time to make a move. It's affordable, it is scalable, it's environmentally positive, not only environmentally safe. I think that it's time to stop talking and start doing.
All right, so start taking action. And you are part of the third cohort for Climate Scale Up. Why don't you tell us a little bit about your experience so far and how that's going?
It's been amazing. You've been vetting the best CEOs out there, and I'm surrounded by impact.
Yeah.
So I think that by itself has a lot of value to us. And also anyone who is in the climate space knows that we work together. We don't see each other as competitors.
Yeah.
So it's been great for us.
Well, thank you so much for joining the cohort and joining us in Davos.